right, guys, give me a sec. Okay, so back to what we're doing in the end of the previous video, guys. So what we're doing is we're working on filling out the unit circle, and we're working on just reviewing how we do our angles for these guys over here. So it was 0, pi was 180 degrees, pi over 2 was 90 degrees. That means this next one is going to be 3 pi over 2, which is the same thing as 270 degrees. Now these points are the easy ones to remember. We're just going to look at our x and y coordinates on our plane here, and we get these 4 values like this. Now the other 3 that we needed to, so let's back up for a second. Next, I'm going to do my 45 degrees. Okay, so this is 45, plus 45 is 90, plus 45 here is 135, plus 45 is 180, plus 45 is 225, plus 45 is 270, plus 45 is 315. Okay, now the way we do these ones in radians is 45 is half of 90. So it's going to be pi over 4. Okay, now if I'm going up by 45, it's 45 plus 45 is 90. It's the same thing as me adding pi over 4 over 2. So pi over 4 plus pi over 4 is pi over 2, plus pi over 4 is 3 pi over 4. 4 pi over 4 is pi. We have 5 pi over 4 here. 6 pi over 4 reduces to 3 pi over 2, and then we have 7 pi over 4. The other ones, we're now going up by 30. So I have 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, and we have 330. So the way we did this one is that if I go 180 and divide 180 by 6, I get 30. So therefore, if I divide pi by 6, I get an angle of pi over 6. Now it's 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6 simplifies to pi, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, and then 11 pi over 6. I can reduce some of these guys as well. 2 pi over 6, I'm going to cross this out and write pi over 3. 4 pi over 6 is 2 pi over 3. 8 pi over 6 is 4 pi over 3. 10 pi over 6 is 5 pi over 3. There's reduced. So now we've done all of our angles in degrees and radians. Okay. Now, what we did on the previous screen was we calculated the points at 60, 45, and 30, and we got these values here. So what I'm going to do next is I'm going to put the points of each one of these guys. So we have these sets of points. Now, here's the pattern. All of the denominators here, everything is over 2. Okay. The pattern for the numerators, we go root 3, root 2, 1. For the x values, for the y value numerators, we go 1, root 2, root 3. Okay, so this is how we kind of memorize the first quadrant. Okay, now how we fill out the rest of it is that the numbers are going to be the same, but just either the positive or negatives, the signs of the x and y's are going to be different. So if I look at the 60, well, 60 this point is the same as 120, but it's been reflected in the y-axis. So all these points to get into quadrant 2, we're going to reflect them in the y-axis. That means our x values are going to become negative. So at 2 pi over 3, we have negative 1/2 root 3 over 2. We have negative root 2 over 2, positive root 2 over 2. We have negative root 3 over 2, 1/2, and we have the point negative 1, 0. Okay. Similarly, if I take these 3 points and reflect them in the x-axis, I'm going to get these points in quadrant 4. So in other words, the x values are going to stay the same, but the y values are going to become negative. So we get root 3 over 2, negative 1/2. We get root 2 over 2, negative root 2 over 2. We get 1/2 negative root 3 over 2. So now I'm going to take, it doesn't matter, I can take the points in quadrant 2, reflect them down in the x-axis to get my points in quadrant 3. So in this one, the numbers are going to be the same as the ones up here, but the x and y's are both negative in this quadrant. So we have negative root 3 over 2, negative 1/2, negative root 2 over 2, negative root 2 over 2. We have negative 1/2, negative root 3 over 2. And there is our very sweet unit circle that we filled out. Okay, so guys, as part of your studying, you need to do this 6 or 7 or 8 times and kind of practice this so you can do this for free. What you're going to find is for the rest of this unit and in chapter 5 and in chapter 6 that you're constantly referring to this unit circle all the time. Okay, so if you don't get this one consistently right all the time, the rest of the unit is going to go really, really rough for you. Okay, so this is one of those skills that you need to go and learn very, very well for the rest of the course. Okay, so all example 7 is to determine the coordinates of each point. Okay, so if you remember at pi over 4, let's go back to the previous screen. That was this value here. Our point was root 2 over 2, root 2 over 2. So I'm going to put, so all we're doing is we're going to be looking up these points on our unit circle like this. 7 pi over 6. Guys, I know these values, but you would look this up on your unit circle. And we're going to get negative root 3 over 2, negative 1/2. 5 pi over 3. I'm going to look up this point on our unit circle. It's going to be 1/2 negative root 3 over 2. Just going to confirm that. 5 pi over 3 is here. Yep, it's 1/2 negative root 3 over 2. 11 pi over 6 is root 3 over 2, comma negative 1/2. And we're just going to be like looking this up on our unit circle and figuring out your answer that way. Okay, the points P of negative 25 pi over 6 and PQ of 11 pi over 12 are on the unit circle. Determine the shortest distance between P and Q along the edge of the circle. Okay, this was a diploma question for a while ago. I think it was in one of our review booklets that we've had. So this is kind of a good question to kind of put in our notes over here. First of all, I want to figure out what's this value here as a principal angle. If I go negative 25 pi over 6, I'm going to add 2 pi. And 2 pi, if I go times 6 is the same thing as 12 pi over 6. That means I get negative 13 pi over 6. Do it again. Plus 12 pi over 6 is negative pi over 6. And if I go negative pi over 6 plus 12 pi over 6, I get 11 pi over 6. So what this is saying is point P, 11 pi over 6 on our unit circle, is this bad boy right over here. This is point P, okay? And this is 11 pi over 6. Okay, what's this guy over here? 11 pi over 12 is going to be this one right here. Pi over 12. Okay, so the idea is the shortest distance between this point and this point is going to be along this arc length, this sector angle. So we need to figure out what this arc length is over here. Now, if you remember what we learned in topic 4.1, we have a formula, which is A equals R theta, which is our arc length formula. Now, what I need to figure out what this angle is over here in radians. So to do that, I'm going to take this angle, 11 pi over 6, subtract 11 pi over, that's 12, not 2, guys. Subtract those two values, and that should give me this angle here. So if I have 11 pi over 6 minus 11 pi over 12, I'm going to multiply times 2 to get a common denominator of 12 here. So we get 22 pi over 12 minus 11 pi over 12. 22 minus 11 is 11 pi over 12. So this is my angle theta. And since this is on the unit circle, we know that radius equals 1. So therefore our arc length is 1 times 11 pi over 12, which equals 11 pi over 12. And this is our answer to this question over here. Okay, the points 1/2 root 3 over 2 and negative root 2 over 2 root 2 over 2 are on the terminal arms of two different angles in center position. Calculate the measure of angle theta between the two terminal arms as an exact value expressed in radians. So the idea we want to do here is we want to recognize this point. Okay, I'm just going to go back a few pages over here to my unit circle. And what I'm hoping you recognize is that this point, 1/2 root 3 over 2, corresponds to this angle of pi over 3. So we know that this angle, which is the same thing as from here to here, is pi over 3. Now for the second point, negative root 2 over 2 root 2 over 2, same idea. I'm going to look back to my unit circle. That is this point at 3 pi over 4, negative root 2 over 2 root 2 over 2. That's this angle here. So I'm going to go back and label this guy as 3 pi over 4. And that's going from here to here, which is 3 pi over 4. So the angle between them is going to be the big angle minus the small angle, 3 pi over 4 minus pi over 3. So we need a common denominator to subtract these fractions. So I'm going to multiply times 3 over 3 for my first fraction. My second one I'm going to multiply times 4 over 4. So we get 9 pi over 12 minus 4 pi over 12 equals 5 pi over 12. And that's our answer for example 9. All right, guys, I know that was a very long lesson. I know it's kind of 2 videos for this one over here, guys. I hope this makes sense. And as always, guys, please send me a message or talk to me in class if you have any more questions. See you in the next video.